Welcome to this video. In this video, we will start introducing functions. Many often we have to repeat a piece of code many times. So in order to repeat a piece of code many times without repeating the code itself, we put the code in what we call a function. You can think about a function as a mini program that executes on demand when the function is called. There are two kinds of functions. Functions that are written by some other people, which are functions that we use, and functions that we define ourselves and we call in our own code or make it available for other people to use. So in order to use functions, we have to understand how those functions are called, but then in order to write our own functions, we need to understand the anatomy of functions in Python in order to define our own functions. So calling existing functions is something that we have done before. For instance, remember the function print that prints whatever you pass to it. That's a function, and in order to call the function, we use the function name and two parentheses, and in two parentheses we pass what we call parameters to this function. Now some functions take parameters, some functions don't take parameters, some functions take one or more parameters, such as the function print. So it's very important to understand what the function itself takes in terms of parameter. It's always a useful idea to check the help of a certain function, because that will give you a detailed information about what the function expects in terms of parameters. For instance, this says that the function print takes a bunch of values to print, but it also takes other two optional parameters called separator and the end of line, as well as other parameters that are not very used most times. So we can call the function, pass in one value, multiple values. We can also provide this optional parameter called separator. If I want to separate these values when they're printed, I can, with a certain separator, I can provide the value of the separator here. We've used many other functions. For instance, the function type is a function that, given a value or a variable, is going to give you back the type of that variable. So to call an existing function, we type in the function name and then two parentheses. If a function takes parameters, we list these parameters. If it doesn't take any parameters, we still need the two parentheses. So for instance, if I want to print just an empty line, I can do print and do parentheses. If I forget the parentheses here, Python is going to interpret this as a reference to the function. So it's basically would tell me that this is a reference to the function print. This is not invoking the function. This is just the name of the function. Let's take a look at defining our own functions. Let's say I want to define a function add that takes two parameters and returns the addition, the summation of these two parameters. To define a function, I need to start with def for definition, and then I list the function name. Now this is up to me. I can name my function whatever I want. And then in two parentheses, I list the parameters that this function takes. In this example, my function takes two parameters, and again, this is up to me to name these parameters. I named my parameters x and y, separated by commas. And at the end, I have a colon to indicate that everything here belongs to the function. This is called the header of the function, and this is called the body of the function. In this simple function, we only have one liner as a body, but generally speaking, this can be as long as needed, depending on how complex the function is. This whole thing is the body of the function. That remains true. At the end of the function, if the function returns a value, we have this statement return. Return basically returns a value to whoever is calling the function. This function returns x plus y, so it's returning x plus y. If the function doesn't return any value, that's still fine, but that in this case, the function by default will return none. So this is one way to define functions in Python. The other way to define functions in Python is by writing a Lambda expression. Now, functions defined using a Lambda expressions are very simple functions, because the Lambda expression, as the name implies, is just an expression. It's a one-liner. It only enables you to write one line in the function body, which means your function is so simple that it can be put in one line. A lambda expression is very useful because many often we just want to write a helper function that we're going to use only once. So instead of defining it, we can just write a lambda expression. That's what I'm doing here. My lambda expression here is a lambda expression that takes two parameters, x and y, and the result of this expression is x plus y. Now lambda expression, if it's not assigned to anything, will be an anonymous function. It's a function that doesn't have a name. Now obviously we want to call this function, so in this case I assigned it to a variable called add, and then I call the function by doing add1, 2. So assigning a function to a variable, what does that mean? Well, in Python, functions are what we call first-class citizens. They're actually like types. We can have a variable of type integer and we can have a variable of type function. And that's what I have done here. The value of the lambda expression is a function, and I assigned this function to a variable called add. Now what's add? It's a function. How do I know the type of this variable? Well, type add. And it's going to tell you that this variable is a function. So this is interesting because Python treats functions as a type. And this type has a very useful operator called parentheses, and that's how you invoke the function. Add 1, 2 is going to be 3. On the other hand, if you have a variable like x and the value of x is 4, that's an integer. You can do x of 6. It will tell you, well, this integer object is not callable. So basically that's not a syntax error. This is a type error. Python is complaining that, well, this is not a function, I cannot call it, which basically means that function is a variable, but it has a special feature of being able to call it. Now this is a very powerful feature. I will get to it towards the end. It means that we can also pass functions to other functions, and we can also treat functions as variables when we are passing them to functions. Now, for the purpose of this discussion, I just want to talk about the lambda expression. In this case, the lambda expression is one-liner that taking two parameters is just add them. We will see use cases of the lambda expression in the future, and you'll appreciate why they are useful when we look at these use case scenarios. For us, so far, we will be using mainly regular functions. Okay. So let's take a look at this function here. This function takes one value and it returns the real part of that value, assuming it's a complex number, the imaginary part of this value, and also takes the conjugate part of this value. So it's returning three things. Now, if you're coming to Python from a different language, such as Java, for instance, this will be really, really puzzling. If you don't have a previous background in programming, you can actually understand the function as being able to return an arbitrary number of return values. Now, if you're coming to this from another programming language, this will be puzzling because you know that a function is limited to returning one value. So what's going on here? Does a function return one value or multiple values? If I call the function real imaginary conj here and pass a complex number, you can see that I'm capturing the three values r, I, and c, real, imaginary, and conjugate. So it's as if my function has returned three values, which is great because now you can think about a function as programs that take an arbitrary number of input in terms of parameters. This one takes only one, and they can also return an arbitrary number of return values. Now, under the hood, this is not true, strictly speaking. When I return multiple values, the function is basically returning a tuple, which is kind of like a list of values. So when I do a real imaginary conj here, the function basically returned a tuple. And this tuple has three components that they can be accessed by indexing 0, 1, or 2. So the function in Python is returning only one value. But if I list these values in commas, Python by default is going to pack them in a tuple. Now, when I capture the result of a function like here, the result will be a tuple. It's kind of like a list. We'll talk about the differences between tuples and a list in a future lecture, but you can think about this as a list. So Python is packing these values in a tuple. When I capture these values here in 3 different variables, once again under the hood, Python is unpacking the tuple to separate values. So long story short, if you don't care about the technicalities under the hood, you can think about a function as returning multiple values. Under the hood, we are packing these values in a tuple and unpacking them here when we are assigning them back to variables in our code. But that's to say that we can really think about functions in Python as returning, as being able to return multiple values. If we kind of understand what's going here under the hood, there is no limitation of the function returning one value. Now we're going to talk about the parameters of a function. Now, when we define a function, we basically list what we call arguments. Arguments are the variables in the function definition. And those arguments have to be supplied with values when we call the function. The values we supply to the function arguments are called parameters. Now, for the sake of simplicity, I'm going to call both of them parameters. But once again, strictly speaking, whatever we list in the function definition are called arguments. Whatever we pass in here are called parameters. Okay, so what do we have here? We have a function called Fibonacci. This function generates a list of numbers based on the Fibonacci sequence. We're not really concerned about what the function does for now. For us, this function takes one parameter and returns a list. Okay. Now this parameter, or strictly speaking the argument here, is assigned a value when we call the function. That's why when we call the function Fibonacci, we have to supply values for the parameters, or parameters for the arguments. If I don't do that, Python is going to complain like, I'm missing a value of one positional argument n. Give me the value of n. I don't know the value of n. I need the value of n to operate. So I need to provide the value of n. Similarly, if the function takes multiple arguments, I need to provide parameters. I need to provide values for these arguments. So here is another version of the function that takes 3 parameters, 3 arguments, n, a, and b. Well, to call this function, I need to supply n, a, and b. If I forget, if I only supply n, now notice once I run this cell, it's going to override the previous function. It's going to complain that, look, I'm missing the values of a and b. Give me the values of a and b. So I have to give it the value of a and b. Those kind of arguments are called positional arguments because they are placed in a sequence, one after each other, and I need to supply the values of these positional arguments exactly in the same order in order the function to be able to execute. This may be a bit limiting, especially if some of these arguments are really optional. They're not needed for the operation of the function. You know, what if most of the time, 99% of the time, a is 0 and b is 1, but I still would like the user of this function to provide different values of a and b if they wish to do so. Then we can provide default values for these arguments. So I can say I have 3 arguments, n, a, and b, but the default value of a is 0 and the default value of b is 1. So here, the user of this function is only obliged to provide the value of n. Because if they omit a and b, a will be 0, b will be 1. But they can change that. They can provide a value for a and provide a value of b if they wish to. Notice again that they are forced to provide these values in exactly the same sequence here. If you do 10 and 2, this means the value of n is 10 and the value of a is 2. If you want to provide a value of b, you need to provide the value of a here because you're listing in the same sequence, the same position. What if you don't want them list them in the same sequence, in the same position? Well, Python has options. Again, Python is all about giving us options. And those options may seem confusing at a bit, but they really provide nice ways to interact with functions in this case. If we don't want to list the values of these arguments in sequence, we can use what we call flexible arguments. Basically, I can tell Python the name of the parameter, the name of the argument, and its value in this syntax. Argument name equals value. So I can tell it, well, I want b to be 3 and a to be 1, and that would work. I can also tell it that, well, I only want to give you n, the first one, and b, I don't want to give you a. But in this case, I have to say b equals to 3, because if I omit b, 3 will be assigned to a. So I want to tell it, well, a will remain 0, that's the default. I want b to be equal to 3, and that would work too. So those are called flexible arguments, and for positional arguments in the function, you can call the function using flexible flexible parameters here. So if you wish, you can say, okay, b is 3, a is 1, and n is equal to 10. The moment you do that, there is no ambiguity. Python will be able to match n to n, a to a, and b to b. Well, obviously, those have to be the name of the parameters. Like, you can't do c is equal to 1 because there is no such thing in the function. It doesn't take a parameter called c. Okay, so when we're calling the function, we have an option of providing positional values to the arguments in exactly the same sequence. And if we do that, we don't need to list the argument name, or we have the option of providing a flexible argument. We list the name of the argument equals its value, and we can mix and match. But when we mix and match, we first have to start with the positional arguments and then switch to the flexible argument. So I cannot do something like b equals to 3, a equals to 1, and then 10. That's not going to work because you have to start with a positional argument. Similarly, you cannot say b equals to, so if you do 10 and then, for instance, 1, you cannot change your mind on a because a now is taking the value 1 and you're providing another value for a. Okay, so we start first by listing the values in positional arguments, and then we can do flexible arguments if we wish. Alright, so to make things more interesting, again, Python provides further options for us of defining our own functions. There are two special kind of arguments called variable arguments or star args, and keyword argument or double start key w args. What are those? Those basically allows you to pass unlimited number of positional arguments and an unlimited number of flexible arguments. So we're not going to use them, but we're going to see them used very often in functions that we use. That basically allows the function to capture any number of arguments. So for instance, this function is called catch-all. It takes args and keyword args, meaning all the positional arguments that I pass to this function are going to be assigned to the variable args, and args will be a tuple, kind of like a list. So if I provide multiple of these arguments, they will be captured in args. The keyword arguments will be captured in key w args, which will be a dictionary, something we will see in the future. Alright, so now we are going to talk about this really exciting feature of Python, and it may be confusing at first sight, especially for people who are not used to functional programming. So once again, functions are first-class citizens in Python. It means that any function we defined, the name of the function is basically like any variable. It's a variable that has a type, and the type of the variable is function. It's a variable that can be assigned and assigned to, very much like any variable. So if I can do another variable inc2 equals to inc, it means now I have two references of my function. I can do type inc2 and it will be a function. I can call inc2 very much like calling inc because it refers to the same function. Okay, so this is interesting, and it allows me to do something really very useful, which is to use a function as a parameter to another function. Let's take a look at this example. Now I have two functions, inc, which increases the value of its parameter by 1, and dic for decrement, which decreases the value by 1. Let's take a look at this function. This function is called twice of that. It takes one parameter x and one parameter f, and what it does, it basically calls f on f of x. So if we do twice of that, inc, for an inc, what this will do, it will do inc of 4, which will be 6. If we do twice of that of decrement, it will be do dec of 4, which will be 2. Again, this is like any other argument. This argument happens to be a function. Obviously, if it's not a function, I will get an error when I will try to call the function. It will say that int object is not callable, right? So it has to be a function that we can call. And that can be any function. Let's try it with the function print. What does it do? Take a moment to think about it. What it will do, it will print of 4. So first is going to print 4. Now the function print doesn't return anything, so by default it returns none, so then it's going to print none, so we see 4 and none printed out. Similarly, I can do use the function type. What do I get here? I get type. What? Well, here's what we get. We basically got type of 4, and we get an integer. What's the type of int? Well, int is a data type, hence the type of int is type. So that's what we get, type. Twice of that of 4 type will be type. So that's to say that this function takes another function as a parameter and uses this function in its code. Let's take a look at, well, here is another example before we switch gears. In this example, I'm providing a liner function in a lambda expression, twice of that 5, but I want to multiply that number. So my one line function is lambda x times x. And the result is 625 because I'm multiplying first, I'm applying this function x times x on 5, so I get 25. And then I am applying the same function on 25. 25 times 25 is 625. So those functions as arguments to other functions are really commonly used in order to tweak the behavior of some functions. Let's take a look at this function called sorted. Sorted basically sorts any sequence. For instance, if you pass a list to sort it, it's going to sort this list. We can take a look at the help of this function. It basically says return a new list containing all items in an ascending order. So that's what it does by default. It returns them in ascending order. But it also has a custom key function that can be supplied to customize the sort order, and also an optional reverse flag that can be set to true to make it in a descending order. Okay, so it means that if you wish to customize how sorted behaves, you can pass in a function called key that determines the key of the sort. What does that mean? Let's take a look at this example here. Say, for instance, I want to sort these numbers in a descending order. Well, obviously I can put reverse is true here, and that will sort them in a reverse order. However, I can provide a function, a key function. The key function basically will convert each one of these values to another value before being sorted. Now, I'm not going to get the conversion here anyhow, but I'm going to get the original numbers, but those numbers, the conversion of these numbers will be used in order to sort these numbers. Okay, so what I get here basically, because I'm multiplying each number by the -1, I'm getting the sort in reverse order. Let's take a look at this example. I'm sorting using the function ABS. The ABS stands for absolute values. So ABS of -4 is 4 and ABS of 4 is 4. When I set my key function to be take each value and take the absolute value, then I'm sorting by the value of the number regardless of the negative or positive sign. So I'm sorting by magnitude, so to speak. So what I would get 1, 2, and then minus 2, 3, 4, 5, 6, and then minus 20, because I'm completely ignoring the sign here. So thus, providing a function here, a key function, is allowing me to fine-tune the behavior of the sort function. Let's take a look at one last example here. In this last example here, I'm going to have a list of things. So let's do apples, oranges, I don't know, cat, dog, and a very long programming item. Okay, so if I do sorted list 1, by default it's going to sort in alphabetical orders. That's the default ordering of the sort. What if I want to sort by the length of each one of these values? So for instance, I want A followed by cat and dog, followed by apples, oranges, and programming. Well, what I can do here, I can do sorted list, but then I can provide a function to convert each one of these items to a number, which is the length of the item. So I'm going to use the function len. So the function len is already there. I just provide keys len, which means that I'm going to use the length of the word in order to do the sort. And here is what we get: A, cat, dog, apples, oranges, programming. If I want to do this in the reverse order, I can do reverse is true, and I get this sorted in reverse length, meaning I get the longest word first and the shortest word last.